Hey, what's up, guys? Yeah, so today, I want to share with this interview question, or not, probably not interview, but probably the question which is interesting, and it's like solving this kind of, you can change this probability question into some geometry problem, and that's the technique which solving this problem is interesting. So share with you guys, and you guys subscribe to my channel if you want to see more probability interview question or some interesting question. That you can subscribe to my channel. Okay, and then go to the list that I post below. So choose xy xn from 0 to 1, then the PNP probability that xi plus 1 is equal to 1, and then for I from 1 to -1, and then we want to prove that the limit n goes to infinity, 1 over n roots of Pn will exist and compute. Okay, so this problem is geometrical, right? So, okay, so it's geometrical. So maybe the ways we solve it at n equals to 2, right? So it's very simple that we just say x1, x2 is equal to 1. So it's very simple as geometry. So it's from 0 to 1, 0 to 1. So it's less or equal to 1. So it's this. So the answer will be, let's call it p2 half. Okay. So now for n equals to 3, that we have x1 plus x2 less or equal to 1, x2 plus x3 less or equal to 1. Okay, so we can do what? We can just do the integration. So it's very simple. The x3 is bounded by 1 minus x2 and 0. And x2 is bounded by 1 minus x1 and 0. And the x1 is no constraint. Okay, so this is our P3. Okay, so usually you can just do, if you have that computer that you can, or Mathematica that you can just whatever do this computation very easily. And maybe, but the problem is that even though you keep computing, that you will not see obviously solution. So this is the hard part of this problem. Okay, but let's do this. So 0, 1 dx1, 0, 1 minus 1 dx2. So this is 1 minus x2. And that is 0, 1 dx1. So this one will be x2 minus x2 squared divided by 2, and 1 minus x1, 0. So you get 0, 1 dx1, 1 minus 1, 1 divided by half, 1 minus x1 squared. Okay, and obviously that you get x1 minus x1 squared divided by 2 minus 3 divided by 1 minus x1 to a cube. And for this one, that you might need to add 1, right? Because that's always 1, 0. So for 1, you get half. For 0, you get minus this. And let's see. So for x1, let's see. x1 minus x1 squared divided by 2, and the plus, sorry, this should be 6, right? Because, yeah, sorry, it's 6. So half minus 1 over 2 minus 1 over 6. So it's 1 divided by 3. Okay. Okay, so I use Mathematica to do some numerics. So for example, this one is like you integrate x3 from 0 to 1 minus 2, and then 1, and the previous one. So this is P3. P3 is 1 divided by 3 as we compute, and you can compute P4. Okay, and then you can compute P4 to be 5 divided by 24. Okay, so we get P2 is half, P3 is 1 divided by 3, and the P4 is 5/24. And then actually you can compute here, right? You just easy compute P5. But what the hell is going on, right? If you compute B5, then you get 2 divided by 15. And if you do the Taylor expansion of 1 plus sine of x divided by cosine of x, then you will see that this is half, 1 divided by 3, 5 divided by 24, 2 divided by 15. Okay, so if you have some like intuition, then you might guess that the Taylor expansion of 1 plus sine divided by cosine will give you the probability. Okay, so the problem is, why is this? Okay, so now this is our main task, proving this is true. So our goal is to prove f of x, Pnx of n, and from 0 to infinity finally will become the previous one, which is 1 plus sine of x divided by cosine of x. So this is our goal. So this is why this problem is interesting, right? Because you're just solving some geometrical integration, which is some region, and I guess it's some highly polytope, and they're finally become this. Okay, you can try to prove by yourself. It's interesting. And obviously, by definition, your Pn will be 0, 1 ds1, 0, 1 minus 1 ds2, and 1 minus 2 dx3. Keep going. And finally become 1 minus xn minus 1, 0 dxn minus 1, 3 dxn. Okay, but it's very difficult to do this f of x, right? So the idea is that we define p of n y to be 1, 0, and then 1 minus y, and the pn minus 1 t dt. But this is the difficult part, that because in this pn is number, right, hard to do. So let's introduce some parameter on this integration, and then we define this. Okay, so this will make everything amazing. So let's define f of xy to be pny xn and n from 0 to infinity. Okay, so let's attack this question. So let's attack this one. Okay, and obviously that one can easily compute the first one. Let's define p0 and the p1 to be 1 and p2 is half, and the p3 is 1. We already compute. Okay. Okay, so let's working on this. So let's write f of xy to be 1 plus, right, this n from infinity xn and 0, 1 minus y, pn minus 1 t dt. This is come from this definition. Okay. Okay. And now we can just get x out and put 1 minus y n from 1 to infinity, and xn minus 1 pn minus 1 t dt. So this is like we change integration and sum. Right? So usually you need to prove all these guys uniform convergence if you know some analysis, right? But you can prove by yourself. I guess this is probably not so trivial, but so this is why you need to check this uniform convergence. Okay, so this is 1 plus x, and you can see this guy, right, will give you the fxt, right? Because by definition, this guy is just xn pn, so this guy is just this. And you know that yeah, you can, because when n equals to 0, that you can ignore first term, because there's a so you got these ones, this. Okay, so this gives you a hint to solve this question, because it looks like there are some differential equation, right? Because you write something into the integral of it, so you can do the differential. So what should we do? Let's do some differential. So if we do a partial yf, that we get minus x, right? So we get partial y. We're doing derivative x on here, right? So by the chain rule variable, that you just plug x into the you plug t into 1 minus y, right? So and then since there is a Leibniz differential rule, right? So you need to take the minus y here. And if you plug x0, x and 0, so you get minus x fx0. Oh, sorry, it's 1. And you can check that obviously at fx1. So what is the fx1? So if you plug fx1, then by definition, you get 1, right? So this guy must be 1. Oh, sorry, minus x. Okay. Okay, so this tell you that this tell you what? This tell you that so your fy of xy is here. This is partial derivative partial derivative of f respect to y is minus x fx 1 minus y, and then we get this. So let's do the second derivative. Okay. So since we need to solve this as a differential equation, right? So let's do this again. Okay, so let's do it second time. So if you do the y again, that you should get, and right, you plug my 1 minus y, so this guy should be plus, and you get minus x squared f x 1 minus y, where we know this, we know let's see, sorry, this is x y, right? So when you plug second derivative f of y x1 minus y, you need to plug y to change it to minus y. So this guy will be y, because you use this equation again. Okay, so now you have partial derivative on y second times is minus x squared or fxy. Okay, so basically it's just the same as if you want to solve this, right? So if you want to solve this, right, square y, then your answer will be cosine a of cosine ax plus b sine ax. So in this case, x squared is our variable, so our f will be constant a, but now we're doing y, right? So this is a of x sine of xy plus b of x cosine of xy. Oh, very difficult. Okay, so now what should we do? We just plug whatever we have, right? Okay, so yeah, so let's come. So we have fy x0 is minus x, and fx1 equals to 1. Okay, so let's consider fx1 equals to 1, and fy of x0 equals to negative x. So if fx1 equals to 1, means that what? So we get 1 of a of x. So sine of x plus b of x cosine x, right? Okay, so this one looks tricky, but okay, so this one cannot solve the question, right? Because you have two variables. Okay. By the way, you cannot say that sine squared plus cosine squared is 1, because you don't know where a is, right? For example, if a is 0, then b is 1 minus cosine, 1 divided by cosine, right? So now if you do the derivative act on y, then let's do this. So if you act on y, okay, so you get a of x and the cosine x or xy plus b of x negative sine xyx. Okay, so now let's, why is there's nothing happened? So sometimes late. Okay. Okay, sorry about this. Okay, so this is, there's a when do derivative on x. Okay, so you got this. Okay, so if you plug x0, that you get minus x, and y0. So this guy is a of x, and this guy will be 0 because y0. So from here, that you get a of x is minus 1, and p of x is 1 plus sine over x cosine x. Okay, so this is our results, and finally we have this, right? So finally our results. Remember that our task is to put y equals to 1, right? So let's see. No, sorry, we need to put y equals to 0, right? Because we got 0, 1, pn minus 1t, right? So we need to plug y equals to 0. So when we plug y equals to 0, that the least term will disappear. So our fx y equals 0 will be b of x 1 plus sine divided by cosine times nothing, right? Because y is 0, so this guy's 1. Finally. Okay, so we know that this guy must be this. So it's a number. Okay, the problem is that the problem what we're asking is that you need to prove this guy converge. So what is this? This is a root test, right? It's a root test. Because f of x converge. Is it really converge? No, right? Because 1 plus cosine of x will blows up at x equals to pi over 2, right? So which tell you that the root test will tell you that this guy, the radius convergent tell you that you need to let me just write down, right? The radius convergent tell you that the convergent radius will be Pn times x n and the 1 over n, right? Less or equal to 1. This is the radius convergent. So you get limit n goes to infinity Pn x less or equal to 1, right? You get this. But you know that when x equals to pi over 2, then you will blow up, right? But x less than pi over 2, this guy will converge. Okay, so which tell you that, amazingly, the limit n goes to infinity, Pn 1 divided by n roots will be 1 divided by the largest convergence, right? So it's 2 pi and 2. So answer is 2 divided by pi. Okay, so this is the answer, 2 divided by pi. Okay, so this is why this question is interesting, right? Because you change this geometry problem into a series, and finally you use the root test of the conversion of the series, and that gives you the answer 2 divided by pi. Yeah, this question is hard, right? You're asking some geometrical shape, and what's the shape? Yeah, let's see. For 2 divided by pi makes sense. Probably doesn't seem to make sense, right? Right? I mean, yeah, it looks like maybe some of them looks smaller, right? But it's 0.5, 0.33, and yeah, I think 5 divided by 24 also smaller. 2 divided by which one is smaller? Yeah, it looks like it keep going down. Right, so it keep going down. So it looks very weird that looks very weird that this answer is 2 divided by pi, right? Because it looks like that it looks like when previous computing looks decreasing, but the answer is actually 2 divided by pi. Okay. Yeah, so it's interesting. Yeah, I mean, yeah, I should use mathematical computer the larger one to see whether 2 divided by pi is, yeah, it's like counterintuitive. I don't know. Yeah, I will check it. Okay, so hope you guys like it. See you guys next videos.